So, talking about the next thing which we are going to discuss is the EIGRP. which stands for Enhanced Interior Gateway Routing Protocol. So it is another dynamic routing protocol, we can say, but the thing varies. Where when we look at RIP purely is a distance vector protocol. But if you look at EIGRP is not a distance vector protocol. It is called as Advanced Distance Vector Protocol, which means if you completely look at RIP, then you would say that when your router is about to make a decision about which path does it actually needs to choose while sending the traffic from one of the either ways that are present, then it's always going to choose the shortest uh, path in terms of the next hops, in terms of the number of hops that it actually needs to cross in order to reach out to the destination.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
But when you look at EIGRP doesn't always work up the situation with the same strategy that RIP uses. So EIGRP is called as Advanced Distance Vector Protocol because it does takes the decision based on multiple factors that are available. So based on the amount of, like, you can say, bandwidth that we have, and there are certain other things that are considered in order to calculate the metric. Its metric calculation is quite complex there, but yeah, we're gonna look through it as well. Now, when you talk about how RIP and EIGRP, or how EIGRP works, the situation up here, we need to go through the EIGRP fundamentals first. So we'll be getting our hands on to the fundamentals. And then we will be talking about how the implementation actually works there. So when you think about EIGRP fundamentals, it is again an open standard protocol. You can implement on multiple vendor devices, but it has become open standard since 2013. Okay, before that, it was a Cisco proprietary protocol. That's why majority of the networks, uh, by the time that EIGRP became open standard, the majority of the network in the world were pretty much settled with OSPF configuration. So that's why OSPF is still kind of the dominating protocol that is used worldwide in most of the production environments. But yeah, there are people who prefers using EIGRP as well. So it is an open standard protocol nowadays, and you can say it definitely is a complete classless routing protocol. Okay, so you have an ability to work up with advertising the subnetted networks there and not the summarized network. So yeah, that's one of the features that it has. Then it, I would say, you can talk about something like the maximum hop count, in which the RIP had the value of 15. Over here, the maximum hop count can be 255, but a default value of 100 is set. So you need to change this particular setting to 255, and then you would be able to like send traffic from like R1 to R2 to R3 and going towards. You can reach out to 250 or 255, like that. So you can have like almost 256 routers serially connected together. That's something that you can do. And after that, the if we talk about the AD value, which is administrative distance value, is 90 for internal and 170 for external. So EIGRP does have a concept of autonomous system, which we're going to get to know about soon. And by using this autonomous system configuration number, or you can say AS number, you can limit the communication between the protocol that you have. You can, for example, if you have a scenario where you have R1 and then you have R2, and you want these routers to talk with each other, and then R2 is connected with R3, and then you want these two to talk with each other, but you do not want R1 to communicate directly with R3. You don't want that. So you can put like a different autonomous system configuration number. It kind of divides the domain, and then it doesn't let the multiple like different autonomous system exchange the routes within. So yeah, that's kind of the thing that is limited over there by using autonomous system number. So when you actually use redistribution, and when by redistribution is basically used for injecting the routes that are being received by some other protocol into the local routing table, which is not really using the protocol from which the routes are received. So if you want like your OSPF routes to be installed in your EIGRP domain, you would be calling them as external routes. So when your router learns about this external routes, it's going to be treated as external routes, and those routes will be installed with an AD of 170 into EIGRP. Cool. Otherwise, every other like normal route that will be exchanged will be installed with an AD of 90. Cool. Yeah. So that's kind of a thing there. Then it is treated as 100% loop free protocol. Okay, it's kind of 100% loop free protocol, and we'll be talking about why it is a loop free protocol or 100% loop free protocol, and then it is pretty easy to configure as well. However, the routing updates are sent on 224.0.0.10. Okay, for RIP it was 224.0.0.9, but EIGRP sends the routing update on a multicast address as well, which is 224.0.0.10 there. And it uses hello packets. It uses hello packets every 5 seconds to maintain the link between the routers there. So it uses hello packets, and then if your hello packets are not received or not echoed back, it also uses the hold time or hold down 15 seconds. So if a specific router who has been a neighbor with another router there, and they are exchanging like EIGRP routing information, fail to exchange three consecutive hellos, then the link will kind of be announced as down, and then the neighborship will be broke, and the routes that were received from that particular router will be removed from the routing table. So it uses like hello time and hold down time in order to check that. Then after that, you have another characteristics there that you can say it supports or it uses protocol called dual, and dual stands for diffusing update algorithm, or you can say it uses dual algorithm itself, right? And then the best feature of it is that allows you to like implement route influencing and all in a better way possible, is its ability that it uses equal and unequal cost load balancing. Okay, so it uses equal and unequal cost load balancing, which means that it's fine if yesterday we saw what is equal cost load balancing, where I specified that by using RIP, it does support up to four equal cost load balancing, which means if you have the destination that is being advertised by your neighboring routers with the same amount of metric there, then you can have four such routes that are installed into your routing table for the same destination. In EIGRP, by default, only the equal cost load balancing is configured, but you have an option to also turn on the unequal cost load balancing option as well. So that's something that is supported in EIGRP. Yeah, so these are kind of the basic fundamentals that we had to cover. Any questions? Varun, Anish, are we good? Vikram?
Yeah, we're good.
Yes, yes.
Yeah.
All right. All right. So we're gonna see now how EIGRP neighborship actually works up by considering the thing. So let's say that we have, for example, R1 here, and then we have R2. And then in R1 and R2, you kind of connect a link there. Sorry. Yeah. And then you have a network call, let's say 12.0.0.0/24, where dot one is here and dot two is here. And you guys are looking forward to like establish the BGP, oh sorry, EIGRP neighborship. So when you talk about how EIGRP neighborship comes up, then it all starts with the hello packets. So as soon as you kind of configure EIGRP on your device, your router is going to initiate the hello messages on 224.0.0.10. Make sense? So yeah, so hellos will be sent over there, and then R2 is also going to initiate hello back on 224.0.0.10. Now the important aspect is hellos are pretty much important in terms like it does plays pretty much important role in bringing up your EIGRP setup. So there are information regarding your EIGRP configuration and the domain configuration inside these hello messages. So what it contains is there is like after you exchange hello, like if I meet Anish somewhere, I can say, "Hey Anish, how are you doing?" And Anish would also echo me back that, "Hey Abhijit, I'm doing good. How are you doing? Thank you." And once like we match up to our criteria, let's say both of us are speaking in English, right? But if I am like waving hello in English and Anish is waving me back in French, and if I don't know how, about like speaking French, then our parameters are not actually matching. We cannot really communicate together until unless we agree to communicate in a common language possible, right? Just like that, in order for R1 and R2 to exchange routing information, or even to be specific with the term, in order to become EIGRP neighbors, it needs to agree upon a certain criteria uh, for becoming neighbors. If it matches up and with the criteria there on the both sides, then and then only they will become EIGRP neighbors. And what is that neighborship criteria? The neighborship criteria is that first, both the routers needs to be in same subnet. R1 and R2 needs to be in same subnet, which they are 12.0.0.0, so that the link we can between them can come up and they can ping without actually routing being implemented as of now. Then the second criteria is they need to be in same AS number, which means the autonomous system number that you are going to configure when configuring EIGRP needs to also be same on both the routers. And the third criteria is they should have same K values. So K values is something that is configured by default onto the EIGRP configuration as part of the EIGRP configuration, because it uses different K values in order to calculate the metric. Okay, so by default, if you don't play with them, the values are pretty much same on every router. So you don't need to worry about that until unless you have played with it. And then there is an optional parameter as well, which you can consider as the fourth parameter, as you can configure link authentication as well. So if you have configured EIGRP password, then until unless the password matches up as well, you will not be able to become neighbors. But by default, there is no authentication configured. It's kind of an optional parameter there. Cool. So if we say that the AS number that our R1 and R2 are using as of now is, let's say, AS number 100, both of them, then they are supposed to become neighbors. And once they exchange the neighborship, then you can say they will be converged and they will become neighbors. And then there are different EIGRP tables you can see. So you have one as the neighbor table, second, you have topology table, and third, you have the routing table. So once your router is forming up the neighborship with some of the other router, the information about that neighbor is stored into the neighbor table directly. And it will have the information about how is it reachable and so on and so on. So once the neighborship is up, now it's turn to exchange the routing table. So uh, there is like a brief difference between the distance vector routing protocol and the advanced distance vector routing protocol. Okay, so a RIP kind of has the biggest drawback that it exchanges the entire routing table every 30 seconds, right? Because it works according to the periodic updates. But if you look at EIGRP, then EIGRP works with something called triggered updates. Now, what is this triggered updates? Triggered updates means that the EIGRP neighbors will exchange the entire routing table only for the first time that it's gonna be become a neighbor with the router. And after that, it will not exchange any information or any update uh, until unless it has actually some changes into the routing table. Okay, so it's like uses triggered updates, which means the updates will only be sent to the neighbors if there is any change in the network. And when there is a change in the network, even in that change, only the change will be advertised into the update packet and not the entire information. Whereas if we compare the same with the RIP, then RIP advertises the entire routing table again and again and again every 30 seconds, even if there is no change. That's a significant difference between how RIP works and between how EIGRP works. Okay, so once this particular thing is done, once you kind of become neighbors, then you would be kind of exchanging the information by saying, hey there, here is my routing table. Okay, and then the R2 will kind of acknowledge it that I have received your routing table, and then R2 is going to kind of send its own routing. Here is mine as well. So R2 is also going to give its routing table, and then R1 is kind of supposed to acknowledge that. And then the entire information about the routes that are exchanged by the neighbor will actually be stored into the topology table. And then, so here's something that you need to know now. How how EIGRP behaves when exchanging routing information is, suppose that you have R1, and then you have R2, and then you have R3, and then you have, let's say, R4, and then this R2, R3, and R4 are connected to another router called R5, which has a loop back like 50,000. Now, if R1 wants to receive that information about 50 from its neighbor, let's say R2 has certain like around uh, two routes, that actually allows R2 to reach out to ER5. I'm not drawing those routes, but I'm just assuming that R2 has two different paths by using which it can reach out to the destination. R3 likewise has three routes, and R4 has five routes in order to reach out to the same destination there. Now, what's going to happen is R1 is going to query to all of its EIGRP neighbors about how to reach out to 50. So what R2 is going to do, R2 will give the best route that is available into the routing table and not into the topology table. So R2, out of the all the available routes that it knows about, it's only gonna throw the best route out towards the neighbor, saying that hey, there, this is my best route that will take you to the R5 in the shortest amount of time. And then R3 is also going to give the best route it knows about, and R4 is also going to give the best route it knows about. So you still have three different routes by using which you can reach out to the destination. And all of these three routes are going to be installed into the topology table. Make sense? So you will be installing all these routes into the topology table. And out of these three routes, only the best route, which is like the one route, is going to be installed into the routing table until unless there is equal cost load balancing that's happening. If there is equal cost load balancing, then multiple routes are like have the chances to be installed into the routing table, which is pretty fine. But by default, if your load balancing is not equal, and if all the routes that are being exchanged has different metric with those particular routes, then only the route having the lowest metric will be installed into the routing table. That's something considerable information that you need to always be aware about.